go ahead and look and see what we've got here. So the easiest way to think about these things is to think about it in terms of the definition. This is a shape that has parallel sides. Is it ever a square? Sure. Square has parallel sides. Now, we have other things that are parallel that isn't a square. So this one would be sometimes. A rhombus, so a shape that has all equal sides, is it ever a shape that has all equal angles? Equal sides, equal angles that exist in a square. So it seems very strange that sometimes a shape that has this information and a shape that has that information exists in one place. A trapezoid is a parallelogram. This is a shape that has one set of parallel sides. Is ever a shape that has two sets? So this would be never, because this one is one set and this is two sets. A square is a rhombus. A square is something that has all equal sides, so it is something that has all equal sides. This is always. A square is a parallelogram. Does a square have parallel sides? Absolutely. That is always. A shape that has all equal sides is a shape. Oh, I just did this one. Just kidding. That's funny. All right, a shape that has all parallel sides, is it a shape that has one set of parallel sides? A shape that has all equal angles, is it ever a shape that has all equal angles and all equal sides? Absolutely, in the definition. And an enclosed shape, is it ever a rhombus? Yes. We have all sorts of polygons and sometimes it is a rhombus. All right, let's look at this one here. Perpendicular diagonals. If all we know is that it has perpendicular diagonals, that exists in a rhombus, a square, and a kite. It also exists in just a random whatever. If I just draw some, let's see, just draw two things that are perpendicular. So we'll just do perpendicular like this. That's nothing. They are perpendicular, but it is not a specific shape. So the must be is just simply a quadrilateral. But it could be a kite. It could be a rhombus. It could be a square. You can also say it could be a trapezoid, an isosceles trapezoid, but that is not necessary. You would need at least these three things to say. So, concurrent diagonals. Let's draw something that are totally congruent. And so those are equal to each other. If I connect them all, that also is nothing. So it is not anything that it has to be, but here and here we have congruent diagonals, and here we also have congruent diagonals. So we have kind of three places. We have isosceles trapezoid, we have a rectangle, and we have a square. All right, diagonals bisect each other. This is different. We actually have a theorem that we've proven that if the diagonals bisect each other, it will be a parallelogram. So we have done that proof. Why have we not proven anything about these? Because it doesn't give you anything. The proof is just nothing. You don't really get that far. Here is a parallelogram though, so I know for sure it's a parallelogram. So it could also be the three types of parallelograms, which are these. All right, so on to our next one. What is the quadrilateral if? Consecutive angles are congruent. That means that this one, and this one, and this one, and this one are equal to each other. That, my friends, is a rectangle. That is the definition. What is it if they're supplementary? So if this and this are supplementary, and this and this are supplementary, and this and this are supplementary, that would give us same side interior angles that are supplementary, which would give us two sets of parallel. So that is a parallelogram. All sides are congruent. That is the definition of a rhombus. All angles are congruent. That is a definition of a rectangle. One set of opposite angles are congruent. Do what, like 90 and I'm not doing this very well. 90, like really nothing. Shows up places, but it isn't anything. So that one, again, it is a kite as a possibility, but it doesn't have to be a kite. So that one we call a quadrilateral. Okay, we are, the next one, looking to attempt to create a counterexample to find the shape that it must be. So we want the diagonals that are equal, but not perpendicular. So that would put the square out, possibly a rectangle, and they bisect each other. Ooh, loving that. Bisect each other tells us it's a parallelogram for sure. So it's a parallelogram, and then since it is in this realm, it is a parallelogram. This is the first one that is congruent diagonals, but then not perpendicular. So this would be a rectangle for sure. Let's see. They're perpendicular, which could be a kite or a rhombus. One is bisected, which means rhombus is out, so it could be a kite, and not equal. So I look at this and I say, well, let's see. One is bisected. We're going to cut that in half, and it's going to be perpendicular. So do we have enough information? So this is equal to this. We've got our 90 degrees. That means based on side angle side and side angle side, I actually do have a kite. So I cannot draw a counterexample. All right, this one is bisected, equal, and not perpendicular. So not a kite. One is bisected, so not a parallelogram at all. So it looks like we're really just needing to draw a picture of, let's see, equal. One is bisected and not perpendicular. So this here would simply be a quadrilateral. And that would be my counterexample. Last one, bisect each other. Parallelogram, for sure. We have that theorem. So it's definitely a parallelogram, and then it's one of these guys. So this would be equal, and this would be equal and perpendicular. So this one would be a square.